Here we have two posts. This one is 5 feet high, and this one is 10 feet high. And the two posts, they are 20 feet apart. And these two posts right here, they are supported by these two wires that are attached to this stake right here on the ground. And so the question is, where should the stake be placed so that we end up with the minimum amount of wire, meaning this wire plus this wire is at a minimum. So for example, right now the stake is placed 5 feet from the left post. The length of this wire, we call it L, is 7.0717, and that's calculated from this is 5 and this is 5, and we have a right triangle, so we can find L, and L is 7.0717. And then the total length from here to here is 20, so this is 5, then this is 20 minus 5, which is 15. And so this is 15, this is 10, and so we can calculate R, because this is a right triangle. And that comes out to be 18.02776. And so the total wire length, meaning this wire plus this wire, is about 25.09882. And so if we change the position of the stake, and then this length would change, and this length would change, and now we get 25.07557. And now we have 25.02. And now we have around 25 feet of wire. And so that's the problem that we're trying to figure out. Where should the stake be? How far from the left post? So that the total wire length, meaning L plus R, is at a minimum. And so if we call the distance from the left post to the stake X, then the distance from the stake to the right post will be 20 minus X, because the total length here is 20, and this is always going to be 5, because that's the height of the left post, and this is always going to be 10. And so for this right triangle right here, we're going to have 5 squared, and then plus X squared is equal to L squared. And then so this becomes 25 plus X squared is equal to L squared. And then take the square root of both sides. We're going to get L is equal to X squared plus 25. So that's this is the equation relating L to X. And then now let's look at this other right triangle. Here we would have 20 minus X squared plus 10 squared is equal to R squared. So we have 20 minus X squared plus 10 squared is equal to R squared. And so this becomes 20 this becomes 100, and then take the square root of both sides, then we get R equals to the square root of this. And let T be the total wire length. That's going to be the length, this wire, the red wire, and then this wire, L plus R. And so T is equal to this in terms of X, and that's what T is. And we want to find minimum T. So we want to minimize T. T. And so, because we want to know where should X be. What should X be? Because X is the position of the stake. So that the total wire length is minimized, is at a minimum. And so we have seen that as X moves, then the total wire length also changes. And so to minimize T, then what we want to do is find the derivative of T with respect to X. And then set dt dx equal to 0 and solve for X. So that's what we need to do. If we want to minimize T, then we need to find the derivative here and then set the derivative equal to 0 and then solve for X. And that will tell us where the stake should be placed so that we end up with minimum total wire length. And so now let's take the derivative of this and then set of this function right here and then set it equal to 0 and solve for X. And so here's our equation right here, and we want to take the derivative of it and then set it equal to 0. And so first, let's go ahead and multiply this out. 20 minus x squared, that's going to be 400 minus 40x plus x squared, and then plus 100. 100 plus 400 is 500. And then let's rewrite this with rational exponents so we can do the derivative. So the square root is the same as exponent of 1/2, and square root here is the same as exponent of 1/2. The derivative of t with respect to x, so here we have to use the chain rule. And so the chain rule is first do the regular derivative and then multiply by the derivative of the base here, of the x squared plus 25. So it's going to be exponent in front of the base. The base is x squared plus 25. And this is the exponent. So it'll be 1/2 in front of the base. Subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. And then multiply by the derivative of the base. And so that's the chain rule. And then same thing over here. This is the base, this is the exponent. So put 1/2 in front of the base, subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. And then times the derivative of the base. And this base is 500 minus 40x plus x squared. The derivative of x squared plus 25, the derivative of x squared is 2x, derivative 25, the constant 25 is 0. Over here, the derivative 500 is 0, derivative of negative 40x is negative 40. Derivative of x squared is 2x. One half times 2x, it's just x. This is negative exponent, so let's rewrite it with positive exponent. So this is the same as 1 over x squared plus 25 to the 1/2. 1/2 times minus 40 is minus 20. 1/2 times 2x is x. And then this is the same as 1 over this expression with power of 1/2. And then next, this is x times 1, so it'll be just x. This is minus 20 plus x times 1, so it'll be minus 20 plus x. And so this is the derivative of the total wire length. And now we need to set the derivative equal to 0 and then solve this equation right here for x. And so here we set it equal to 0. And recall that we have this right here, a over b plus c over d. Then this would be, we can just cross multiply. This is a times d, and then plus b times c, and then dividing by the product of the two in the denominator, b times d. And so right here, we'll cross multiply, and then dividing by the product of these two denominators. Cross multiply, we get x times this expression right here, and then we get, then this is the same as x minus 20. Minus 20 plus x is the same as x minus 20, and then times this expression, and then dividing by the product of the two denominators. And now this is equal to 0. And again, when we have a quotient equal to 0, then the only way that this can be equal to 0 if the top is equal to 0. Because if the bottom is equal to 0, then we get undefined. And therefore from here, we can say that the top is equal to 0. And then to solve this equation, we're going to bring this expression right here and move it to the left side. And so if it's a plus here, when we move it to the right side, so we're going to move this expression right here to the right side. If it's plus on the left, when we move it, it becomes minus. And then now we square both sides. So it's going to be x squared, and then this expression squared. X squared is just going to be x, and then this expression square, multiply the two exponents together. 1/2 times 2 is just 1. So the exponent right here is 1. This expression right here, the negative x minus 20, when we squared it, the negative becomes positive. And then we get x minus 20 squared. And then this expression squared, we just do the 1/2 times 2, which is 1. So the exponent right here is 1. And then now we'll multiply everything out. X squared times 500 is 500x squared. X squared times 40x is 40x to the third. X squared times x squared is x to the fourth. And then x minus 20 squared is x squared minus 40x plus 400. And then multiply this out. X squared times x squared is x to the fourth. X squared times 25 is 25x squared. minus 40x times x squared is minus 40x to the third, minus 40x times 25 is minus 1000x. 400 times x squared is 400x squared. 400 times 25 is 10,000. And then right here we have an x to the fourth on the left, we have an x to the fourth on the right. So we subtract x to the fourth on both sides, and this will drop out. We have minus 40x to the third on the left and minus 40x to the third on the right. So we add 40x to the third to the left and to the right, then this and this will drop out. And so this is what's left. On the left side, it's just the 500x squared. On the right side, this is gone, this is gone. So we have 25x squared minus 1000x plus 400x squared plus 1000. The 25x squared and the 400x squared, they like terms, so we combine them and we have 425x squared. Now move everything to the left so we can solve for x. When we move this term 425x squared to the left, it becomes minus 425x squared. This term moving to the left becomes plus 1000x. This term moved to the left becomes minus 10,000. 500x squared minus 425x squared is 75x squared. And then now this is a quadratic equation. So we can use the quadratic formula. A would be 75, B would be 1000, and C would be negative 10,000. So solve this equation by using the quadratic formula, and then we'll end up with x to be 20/3 or x negative 20. But here x represents the distance of the distance between the left post and the stake, and therefore it cannot be negative. And so the answer will be 2/3. That'd be 20/3, which is about 6.6. So right now the stake is at 7.8, and so it should be around 6.67 to get minimum. So this is about 6.7. So that's roughly 20/3. And therefore, in summary, if we want to have minimum total wire length, then this stake right here should be placed at the position of 20/3 or 6.67 feet from the left post.